We are going to talk about Newton's first law, second law, while dealing with inertial mass and gravitational mass. Newton's first law. It is, an object at rest stays in rest. When it is in motion, it has a constant velocity. A constant velocity is a constant speed and a constant direction. This is all unless it has a negative net external force. Newton's second law is sigma force equals mass times acceleration. Now we're going to be talking about the two different types of masses, inertial and gravitational. Now let's define inertial mass. Inertial mass is a measure of an object's inertia, or its resistance to acceleration. Now let's talk about gravitational mass. This is used to determine the force, gravity, and weight of an object. The formula is Fg equals mg. The F stands for force, the G's mean gravity, and the M stands for mass. These two are experimentally identical. So now we will be doing a two-string tension example. The problem is a 22 kilogram mass is suspended by two strings. The angle of string 1 is 32 degrees, and the angle of string 2 is 61 degrees. What is the tension in each string? First, you would want to draw out a diagram of the problem given, and then write down all the known variables. After this, you set up the problem. Now that we got our equation right, let's go over why we're using 10 meters per second as gravity. We are doing this to round up and make all the math easier. So this means we get 220 for the mass times gravity. Now we'll be plugging in our numbers to the equation that we just wrote. This will all be equal and relative to force of tension 1 times cosine 32 equals force of tension 2 times cosine of 61. By expressing T2 in terms of T1 and by plugging it back into the first equation, we can find a value for T1 and then T2. I made T2 equal to T1 times cosine 32 all above cosine of 61. This means that T2 is equal to 1.749 T1. Now that we've got T2, we're going to plug it back into the initial equation, and this will be all equal to 220. After simplifying this, you'll get 2.059 times T1 equals 220. After simplifying this more and doing more math, you'll get T1, which is equal to 106.847 newtons. Now we're going to plug T1 into the first equation, which means we will result in T2 being 186.875 newtons.